And welcome everyone to OpenShift TV Coffee Break. Good morning. Uh,
Morning.
good morning,
Morning.
Liran and Stefan. We have two guests today, and I'll let them actually introduce themselves and who they work for. A little bit of surprise here. Company is Sosivio, and the floor is yours, guys. Why don't you introduce yourselves? Meanwhile, I have my coffee.
Oh, that's good. Good evening. Good morning, everyone. Good evening. Depends on where you are on the globe. My name is Liran Cohen. I'm the CTO and co-founder of Sosivio, predictive troubleshooting platform for Kubernetes/OpenShift.
Hey everyone, thanks for joining. Stephen Thorne here, solutions architect for Sosivio. So anything business, commercial, marketing related, I'm involved with.
Excellent. So, what did you guys prepare for us today? What does Sosivio do for those who are not familiar with it?
Stephen, I'll let you take the floor.
Sure. So Sosivio, do you mind if I share my screen?
Sure. Let's
Cool.
let's share the screen.
Cool. So like we said, Sosivio is a predictive troubleshooting platform for Kubernetes and OpenShift. Today, we're going to touch on a company profile, talk about who we are, what we do. We'll briefly mention our novel methodology called data swirling. We'll talk about a few use cases and case studies, and of course, end with a demo. So
Can't leave without a demo on OpenShift TV. We have to see
course,
the real thing
of
at
course.
some point.
Sosivio has been around for a few years now. While we do work in OpenShift, we also work in any distribution of Kubernetes. We work in completely disconnected environments. So everything that we're talking about and demoing today is just another application, 100% in the cluster itself. So no data offloading. It's not a SaaS tool. It does this in a very resource-friendly way as well. We heavily leverage lean AI and ML to predict and prevent critical failures in Kubernetes environments. We have domain experts both in Kubernetes and AI. We have one of our many experts here for Kubernetes, Liran Cohen, who will dive into the product a bit more in a second here. We are a US-based company. We're headquartered in San Francisco, California, and our R&D is led out of Tel Aviv. You can see on the right side of the screen here, we have just a select number of our customers and design partners. It's just a testament of the different environments and types of companies that we're deployed in and work with.
And many of them are also OpenShift users. I recognize them.
Awesome.
Definitely.
So what do we do? What's the problem that we're solving? I'm sure, unfortunately, some of you have dealt with troubleshooting on Kubernetes. That can be a quick process. It can be a few weeks to solve a single issue as well. It just depends on the complexity of it. But the typical troubleshooting process is you would get an alert, maybe from a platform, a tool you have in your environment, maybe a customer complaint, worst case. You then need to go into and prioritize and understand what is the impact of that issue. Then you go through and identify the root cause, and then once you do have the root cause, what's the remediation? You implement that, and hopefully that does work and fix it. If not, you're kind of going back a few steps there and trying to fix it again. That is, like I said, it can be pretty time consuming. So what Sosivio does, it automates that whole process for you in a real-time fashion. And I'll turn it to Liran to talk about a little bit more Sosivio.
Sure. Yeah. So first of all, if there are any questions from anyone in the audience, I'll gladly answer. And if not, then just to add something important, I think. I used to be, before Sosivio, principal architect consultant for Red Hat. Used to travel around Europe and in Israel. And actually, this is where Sosivio was born. Like the idea, what was missing when I was giving professional services to banks, insurance companies, automotive companies, telco companies. When something broke, it was very difficult to find it. Hence, and we didn't have all the information. Like the information was in Kibana Elasticsearch or Prometheus, and you had to go and dig deep to try and do some kind of correlation or in a external file just to extract all the information, put it on a timeline, and try to understand what happened. So Sosivio does all that for you in real time, meaning it fetches all the information from the relevant entities, pods, deployments, replicas, whatever you're looking at. It gathers it, puts it on the timeline, and then creates a sequence of events. In a couple of minutes. In the meantime, if there is no other questions, Andrea, keep me posted.
At the moment, no questions from the audience. My question would be: you said that it is, and maybe you're going to talk about it. You can work in air-gapped environments, disconnected. Um, um, is there a procedure where you have to somewhat update uh, X information that comes from other, let's say, anonymized experiences or patterns into air-gapped environments? That was my first question. You don't have to answer. Maybe as you go through, it will be clearer. The second is um, you probably have a way to estimate what is the resource requirement based on some parameters of the environment. I don't know, number of nodes, number of pods, number of metrics, or whatever it is. I'd like to understand a little bit that aspect. So if people want to do this implementation, what are the additional resource requirements that is put on the cluster?
Okay, so let's start with the second question, the resource consumption. Resource consumption is something that I was really concerned about even before Sosivio when I used monitoring tools, because if the overhead is like 30-40% of cluster resources,
Exactly.
that's a big deal, right? It's cost and you need more nodes, and then you start troubleshooting the nodes that are running applications to troubleshoot other applications. So that's becoming crazy. Sosivio footprint is negligible. I don't want to say numbers here, but it should be in my vision, the initial vision, it should have been less than 5%, and it is well below 5% of total cluster resources. um, of course it depends on the cluster size. Like the bigger it is, the
Understood.
lower the footprint is, because we distribute the analysis over multiple pods. It's not happening in one big pod or in one storage location. Remind me the first question. I forgot about
The
it.
first question was in many cases
Oh,
where
right.
diagnostics is involved, especially if it involves AIML, for example, um, you recognize patterns, and there may be patterns that have not occurred in their cluster, but they have occurred somewhere else. And uh, you want to take that experience and bring it into the cluster. They may be more cluster related than application specific, but so I would imagine that there's sort of a bootstrap of intelligence that and that's my mental image, right? So it may be completely wrong, but and that you
You're,
update that every now and then, so that can be
you're,
done offline.
you're definitely right. The engines come with, let's call it pre-trained data, sequences that they already know, malfunctions that we already detected and have seen, and are embedded into the product. So you won't have to first find them on your cluster. But even if you don't have those, once a malfunction happens for the first time, we find the sequence and we store it inside your cluster. So it doesn't need to be connected anywhere to understand new sequences or new problems. Once something happens, the pattern of severity between the different signals will appear in our what we call the discovery engine. Sequence will be discovered, and from that point on, that sequence will be detected all the time. The next, you will probably get that sequence
Right.
from us as a pre-trained data set for the engines.
So it's through the disconnected software upgrades
Yeah,
that you
because
get.
most of the environments, and probably on OpenShift, the ones that I used to work with, none of them had internet connection. It was sometimes even worse. The whole organization didn't have internet connection, especially if you're talking about government or army or organizations. That's like completely disconnected, air gap.
And there are still a lot of use cases like that.
Yeah, definitely, definitely. So
Okay,
anything
guys.
else? Let's jump into the demo.
No more questions. You want to go to the demo first? Okay, perfect. Let's just do that.
Awesome. So this is the dashboard of Sosivio. Everybody, it's pleasant to meet you, and I hope it's going to be pleasant for you to meet Sosivio. The main screen that we see right now has a lot of information aggregated to show you the state of the cluster. You have, for example, health scores, which I'll get into in a couple of minutes. That means that uh, what is the status? It's divided into three different categories: platform, which is basically the hardware and the nodes and the OS of the cluster; application, which is actually what is running inside the pods; and deployment, which is basically the state of the deployments, replica set, services. Like if you have uh, um, endpoints for each service, if you have all the replicas in the correct version for every deployment, stateful set, and so on and so forth. And these are the AI predicted failures, meaning these are the actual sequences that we find, and you can see that they progress as time goes on. They start as a warning, then they become an urgent until they reach full failure, which is the red. We will show you exactly the list of them and how you see them and how you deal with them. You also have like a generic inventory here to see the state of pods, nodes, if they are unschedulable, meaning cordoned, or if you have pods that are in a complete state or pending or something similar. The load average of the nodes, which we found and customers found very useful to see at first glance. And then we have something very interesting here. This is the automatic application profiling that Sosivio offers. In here, you see two states, the overallocated and underallocated deployments in our cluster. We'll deep dive into it also. There's a full screen for it. But right now, I would like to go directly to the AI predicted failures, the things that we see here. If we click it or if we go to our command center, then we can see the full list of failures along with the, let's call it the predictive severity of that sequence. And you can see that we have many of those. In fact, we have 107 failures and 68 predictions that things are going to break, and 2 warnings that it's just starting to build the sequence. Well, let's look at the full failures for a second.
I'm not sure if the screen is updating.
You see the list of failures right now?
No, Liran, it's frozen on the cluster overview page right now.
Let me stop sharing and I'll start again.
Okay. I can also share Liran if this doesn't work.
Yeah, it doesn't let me stop sharing. Okay, Stephen, why don't
Let's stop sharing for a moment.
I stopped.
And I'll start sharing again.
Okay.
Let's see if no. So I don't understand why it's frozen.
I think it's something with the browser. Give me a second, I will rejoin.
Okay. Meanwhile, okay. Let's see. Is there a way you can in the meantime continue with the presentation?
Sure. Because we jumped right into the demo, I'll briefly. There is it. Okay.
Liran, let us know when you're ready again.
I think it's okay now. Let me try and share again.
Okay.
Can everybody see my screen?
Now, yes, and I think now it's updating.
Yep.
Okay, good.
Yes.
So we can see some of the failures that are here. There's a lot of failures as I said, this is a demo cluster, but there's still simulation that we run on it. And you see that it is constantly updating every time a sequence completes, meaning a failure starts and fails eventually. then the information here updates. We can see like things from panics that you see here inside pods, and you can see actually the panic itself, why it panicked. And there's a lot of demos here. That was division by zero, which was something simple, and here we have blah blah blah, whatever it is. Um, for Python, Go, Java, Node.js, and C Sharp. And there are also failures that are not related to the code itself, meaning it's stuck in container creating, and you can see that basically the readiness probe has failed and blah blah blah. It couldn't create the container. So basically, you can see everything that happens on the cluster. Let's put this on a 30 issues. See if we have something else. So here we have a configuration issue, which is someone set the deployment to have image never pull. And this one, uh, create container configure, meaning you're probably missing a PVC, and you can see a secret in this case. The secret is missing. So basically, you can see that everything that happens on the cluster that is critical for you to understand and know and deal with, you can see in the command center. So in the mass information, which is Kubernetes, and the different tooling to look at it, it is very difficult to differentiate what is important and what you need to deal with and what is just information that someone spewed out, because developers a lot of times just put log messages for them for troubleshooting afterwards, and as a whole to the environment itself and to your service, most of it is irrelevant. Any questions about this command center for now?
I
'Cause
don't see any questions. I
sorry.
don't see any questions around. Did you want to talk about sequences and kind of the DNA malfunction and kind of like that aspect to
Yeah,
it?
yeah, of course, of course. So the way this works, and let me try and get one of the OM kills. You know what? Let's just open it here. It's probably here. So if I show you a sequence, it is built out of singular events, meaning a lot of things happen to pods, deployments, replica sets, services, whatever is running and is comprising the service that you are providing to end users. There's a lot of moving parts. In order to actually find what happened, you need to get all the information from all of these moving parts and put it on a timeline. And as you can see, this is just a 4 sequence event, but we have a much bigger sequences, up to 18 and 20 events in a sequence, meaning let's say you had a panic inside the pod, which returned 500, and because of that, the pod crashed, and then it restarted. Then all of these things are actually put inside that sequence and on a timeline. That becomes a signature of this mail function. The big concept here is that we differentiate, as you can see, the what happened. This is what you see, the description. This is internal checks that we do from the type, and of course, who it happened to. You can see that there is a namespace here also. Uh, so basically, once a failure happens, we just take the events that happen without the who it happened to. And those events in turn can be used to any other deployment or pod or whatever entity it is. I'm trying to find, oh, here, for example, this is an OM kill. And you can see that the sequence here is much, much longer. It's actually 13 events long. And you can see everything that happened to the deployment on the node itself, the pod. Because, for example, with OM kill, you have 3 different types of OM kill. You have OM kill, and that is instigated by the node not having enough memory, which is nothing you can really do about it. Just move the pod somewhere else. You have an OM kill because you crossed the C group limit, meaning the pod's limit, the container's limit. And the third OM kill is because you created too many sub processes or processes on that node, which is also something that the only way to fix it is to move it to another node. If you don't have a sequence of events, if you don't exactly see what happened, and you see that it was killed by the kernel because the C group was crossed, the C group limit was crossed, then there's no way you can understand how to fix it. Giving more memory to this pod on this specific node will not fix it. Sorry, for this pod, it will fix it. But for pods that were killed because the node was cursed on memory, it doesn't matter if you give it more memory limit or request, because that node doesn't have enough memory to make this pod run. Um, that's it. Steven, you wanted to mention anything else about the command center?
I mean, I'm sure we're going to want to talk about, the application profiling piece there.
Yeah,
So I don't know if you
definitely.
want to jump to that now. Yep.
Yeah. So back when we started sharing, we saw the over allocated and under allocated widgets in the main screen, and I wanted to dive into them for a second and check the application profiling. So application profiling in Sosivio is done in a very special way. The way we do it is we look at pods and basically deployments from the second that they started and up until this point, meaning we look at the behavior, at the dominant behavior of that pod or set of pods, and we determine first of all if the dominant behavior is erratic, meaning there are spikes, memory or CPU, it doesn't really matter. And we check also if it's calm, meaning it doesn't change as much. By the dominant behavior, we actually decide with an algorithm what to put as recommended values for that pod or set of pods or deployment. The reason we do that is because you can imagine that you can have a pod running like crazy, spiking all week, and then on Thursday night it stops spiking because there's not a lot of users or whatever. And then if you try to profile it based on the last hour on Thursday or Friday or the last day even, then you will profile it wrong. You have to take into account its full lifespan and understand what were the maximums and what is the average and what was the behavior that was dominant for that pod's life. So this is how Sosivio does it. And you can see that, for example, for this pod, the request is currently 80 megabytes, which is what we recommend, but the limit is much, much higher than what we recommend. With CPU, this pod probably doesn't do really much, so the recommendation is really low. And these are the values that we have seen. What was the average and maximum for CPU and memory during the dominant behavior period? Let's try to find something that is a little bit more spiky. Maybe this. Yeah, this one has no limits and no requests, which is dangerous to run something like this. So it immediately Sosivio detects that and, of course, gives you the right. Um, what is this? Okay. But you can see that it's almost for any pod, every pod that is running on the cluster. And of course, if you click the recommendations available, you can see exactly what's going on if you're over allocated in the request or limit of the CPU or memory. And of course, you can apply the recommendation. You can click here and apply the recommendation for all containers. There's another button here, especially for developers, because a lot of times you do green, blue, canary, or whatever methodology that you use to deploy your applications, and you deploy them in an environment, sometimes even in production, but they are not running for a week, 2, 3 weeks, and then you start running them. So you want to restart profiling from the second that the pod is actually put into work to actually profile it with the chaotic behavior of real users. Um, Now, just to explain a little bit how all of this magic is done, how do we get this sequence that you see here? This is a panic indicator. Actually, this is not a full sequence, but if we choose a sequence, let's choose one from here. Mm, So how do we get all of these events, and why other tools are having a hard time to check these things? Inside Sosivio, you also have the insights and metric, which you glanced in a couple of minutes ago when I ran through it. This is actually giving you a lot of information that is coming directly from our collectors, not being analyzed or this is actually the raw data that is going through the data swirling mechanism that I want to touch once we finalize the demo. So basically, there's a lot of information that Sosivio reads. We have our own proprietary collectors. We have our own proprietary database, which is a graph database combined with a document store. And that information comes with a very high granularity. For example, I'm sure every developer will love having something like this in their hands. Let's try to find something that is doing some work. So if we take this guy, we go to real-time metrics, and we can see that it is throttling like hell, right? But still, if you see the granularity here is 5 seconds, I'm going to try to find something that is a little
It might have frozen again.
It did.
really.
Yeah. I don't know if refreshing your browser may do the
I
trick.
killed it and restarted it, and it seems like the whole browser is,
Just reloading, maybe? No, not
yeah, and there's
enough.
nothing else open on my computer. Let me rejoin.
Okay. Stephen, in the meantime, so uh, we said that there is that there's so all these data and metrics. I guess they are stored somewhere.
Yes.
As they okay. So I think let's
Very
bring
fast.
again in the conversation.
Yeah, sorry for that, guys.
No worries.
No worries. That's okay. So we're back in business.
Yeah, I guess Chrome doesn't like my computer too much. But
Okay, so we were just to recap. How did we get here again? Um,
so we spoke about the how we get the information for the sequences and why it's very difficult, or I haven't seen any other tools that can have this type of information and this granularity, which is what I was missing again as a consultant, as I mentioned before. The way we do it is using the data swirling methodology, and of course our own proprietary collectors and database. Just to show you the granularity of information that we have inside Sosivio, for example, we're looking at CPU right now, and you can see that every 5 seconds you can have a read, and you can see that it's 0.302 cores. So it's very, very precise. If you have a spike here, if something spikes, you will see it immediately. You don't need to go and dig, because all other tools, especially the ones that are based on Prometheus Node Exporter, are doing averages, so it's very difficult to find something that spikes, or if you are cut off when you request a lot of CPU, or again, same thing goes for memory. By the way, you also have, if you notice here, the red line is your limit that is configured for this pod. The blue one is the request, and you also have the average and the maximum. If I remove the limit, you can see that it zooms in a little bit. If I remove the request, it will probably zoom more. You can see the accuracy here of our reads. Same again, same goes for memory. If I remove them, by the way, the green is very important. That's the maximum that the pod ever consume, CPU and memory. We also have the same for threads. Throttling, which is taken directly from the CFS. This is not throttling right now. Voluntary context switches and non-voluntary context switches, which have indications. Basically, voluntary context switches indicate high I/O, either network or storage most of the time, and non-voluntary actually indicate deadlocks or loops inside the code, things that get stuck or take a lot of time. So that's the granularity of information we have. We also have The network connections from each pod, it will update in a, oh, this one is not connected anywhere. We'll try to find someone that is. Let's take, for example, the CRUD should give us some network information. So you can see that all the HTTP information is here. We can see the APIs that this pod is actually be accessing. How many requests, what is the maximum latency, if it returned 200, 300, 400, and 500. We can see the information that this pod sends, and of course the information that this pod receives. So it's very convenient to see if you have latency between pods here, and to which API. Sometimes the latency doesn't emanate from network problems, but actually from a remote pod that takes time, or maybe a database that is too loaded. So it's very easy to see, as you've seen a second ago. You can see actually a lot of APIs that are being accessed. Let's find something with multiple APIs. We had one a second ago and I closed it. Yeah, you see here, you see two APIs. Maybe one of these APIs is taking too long to respond. So you can see also the maximum latency per API, which is very, very convenient when you're working in such a distributed environment. If we go to the network connections, we can also see the state of connections, meaning, and this is very helpful to detect load balancer or firewall issues between your cluster and somewhere else. For example, if you had a load balancer with a connection limit or a firewall which is just dropping connection, you will probably see fin waits or close connection, basically waiting to go to the next step but cannot. So that's also very convenient to work with and very useful information. Um, any questions so far, by the way, Andrea?
No questions apparently.
Awesome. So we have the same thing that we have for pods, the real-time metrics we have for the whole nodes. Of course, with load average and a lot of other information, but something very interesting here is that we can also see the DNS latency on that node, which affects all the pods on that node, and the SDN latency, which you can see if you click here. We have our own collectors are actually measuring latency inside the SDN, not just between the nodes. Meaning, even if your SDN is slowing down or you have drops or resets or retransmits, it will be reflected here immediately. So also that's a lot of information that you can use to actually determine if the problem is in a pod, a node, a whole network, etc. Again, same granularity also for node information, like what is the usage, what was the maximum usage, how much limits for all aggregated limits of the pods on that node, same for requests, and of course the average. And network connections, again, sometimes nodes have VLANs or firewalls between them, or I've seen also IPsec encryption between nodes. So you can see also all the connections between the nodes themselves. We also have a couple of other things that are worth viewing. Our health checks is basically, to simplify it, when you're troubleshooting, you don't just read logs, right? You run commands, like you check the deployment, you check everything is deployed, you actually run some curls, maybe a dig to see DNS resolution. So Sosivio does a lot of these tests automatically, continuously, on the whole cluster, on the platform, parts, application, as I said, and deployment. These are the health checks. If you remember those are based on the health checks or the proactive tests that Sosivio performs continuously. But these can actually give you a lot of information about a deployment or a namespace or a node, and you can see that you actually can see the state of every health check. And if we go to status equals failure, let's see. So all these things are failing or failed in the past recent time. For example, the Kubernetes API service continuously restarting. It's probably because it's on a lot of load, and this is the demo environment, and we are actually simulating a lot of failures. But if that happens, you usually don't see it. It happens and it restarts, and that's it. You just have slow API communication. You run kubectl, maybe it takes 3 minutes or 2 minutes or half a minute, 30 seconds. So this can give you a lot of insights as of what is wrong with your cluster. Again, this is just for the platform. We have the same thing for the application. You can see exactly which one is in which state and a lot of other tests that we have here. And of course, for the deployment, for example, if you have 5 replicas set for the deployment and only 4 are running, or maybe it's not in the recent version, the test will fail and you will see it here. Okay, unless there are any other questions.
I do have a question.
Sure.
So e- effectively, you have a monitoring capability like these health checks, and these are the actual. So what failure they have happened, and then you have a capability of let's say predicting with a certain confidence that some patterns are occurring and they may lead to failure of different types. Um, can that be somewhat externalized to, for example, a service now, so that if people are not watching the console all the time, they can get alerts and say, okay, you need to look at this, and then understand what is the recommended remediation that you could do. Um, is that something that you guys do already, or is it in the roadmap?
Well, it's a good question, Andrea. Well, we do have integration with Datadog and Splunk, which are used in a lot of NOCs. We don't have an integration with ServiceNow at the moment, but Splunk and ServiceNow and Prometheus and Grafana, sorry, we already have integration for those. So in case, and probably it is in your NOC or your DevOps team, they have a screen in front of them that they look at. You can actually push all the information from Sosivio. All these failures actually push them there, and if there is a failure, you can actually click it, go into the Sosivio dashboard, and view it. By the way, something that is very important that you didn't see in the demo is Sosivio is completely built on RBAC, meaning all the permissions that you have on the cluster will be applied in Sosivio, meaning if Steven is the admin and I'm a developer and I have permissions to see only my namespace, if I use the same username, meaning if I use OAuth to log into Sosivio, which we also support, of course, if I use OAuth, then I get my username, and the same RBAC that applied to me on the cluster itself will apply to me in Sosivio, which is very, very convenient, especially in production environments where you shouldn't have people. You want to let them see, but you don't want to let them touch anything. And that's one of our big customers. How do you say it, Stephen? A top 10 bank,
Top 10
international
bank,
bank. Yeah,
international, yeah.
yeah. So because we can't say the name, so it's a huge environment, a very big environment. Actually, it's multiple environments, but they use it, of course, in development and testing and all the rest. But they found a very nice use case for it, where if something happens in production, they don't have to give the developer kubectl access. They can just open Sosivio and then they can debug whatever they want. They don't have permission to touch anything, and they don't have direct access to the cluster, which
Okay.
is which is one of the things that they found very useful. Another thing that they really are using on a day-to-day basis is they gave the tool to all of their developers, and they reduced. Stephen, give us the numbers. They reduced the
Um,
number of calls to DevOps people by.
I think they said it helps them like up to like 90% reduce the time it takes to fix these issues because they have thousands of developers. They do have some expertise in house, but a lot of things will get escalated up. And these experts in house are spending a lot of time dealing with these developer issues, which may not be super complicated and could be solved, by developers, but they just don't have that knowledge yet. So they're seeing what's going on. They're having the root cause presented to them right there, and they don't have to escalate nearly as many things up anymore.
And that's a very, very important point, Andrea, because these guys, they know Kubernetes. I know because we've spoken to them many, many, many times. They are experts. But how many experts do you have in an enterprise? And when you have, I don't know, 4,000 developers, if even if you have 20 super Kubernetes experts, it's not enough to support the stream of questions and problems that fill up your feed every day. Giving a tool like that reduces that, as Steven said, 90%. That's their words, not ours. 90% of the request to those DevOps experts, Kubernetes experts are reduced. And that frees them to go do important things like automations, evolve the cluster, upgrade things, instead of just answering, oh, yeah, you put an error image never pull, remove it, or the image tag is not correct, or you put a capital letter in the repository name, like these things that happen on a day-to-day basis. And of course, for us, for someone that is very familiar with Kubernetes, it looks like, oh, yeah, it's 2 seconds. For developers that don't deal with Kubernetes, and in fact, don't, if some of them don't even have kubectl access, they do it through the CD pipeline. They just try to deploy and it doesn't deploy. Andrea, my pod doesn't deploy. Okay, go do kubectl. Now you have to do describe or get OYAML or whatever it is you need to do to understand what happened. Instead, give the tool to the developer. Immediately they see that the repository had a capital letter, or the image could not be found because it's not in the repository, manifest not found. And these are just the small, simple things.
So not only, let's say, in production, but also in your phase of test, while developers are still involved, and they can catch. And I guess the system can be trained to detect new patterns once a developer has understood what is happening, or how do you do that?
Well, the system always finds new sequences, but at the moment we actually manually took the sequence. Everything that happens on the cluster creates a sequence. What we do right now at the moment, as we develop our AI engines on and on, we actually have a set of sequences that we know of that are 100% for sure failures, and we exactly know what those sequences stand for, and we give you recommendations for each and every one of them. In the future, there is an engine that will automatically actually find any sequence that we already find. By the way, you don't need to train the discovery engine; it finds everything. The problem is to take those lists that you've seen
Yep.
of events and translating them into something that a developer or a DevOps person will understand.
Okay, I'm checking. No questions related to our topic.
I
There's
hope
another
we're
question I have
raising
to
a
deal
new
with
one.
later on. um, you mentioned that we were talking about it, Stephen, while you were starting. We were talking about the data repository that you have to have on on the cluster. Do you have to install, or does it rely on some database that you have to install as well, or is it its own uh, type of repository?
So again, you have good questions today, Andrea. So this is a good question because a couple of things we forgot to mention. One, Sosivio does not require any prerequisites on the cluster. We don't need storage. We don't need a special cluster or a special node or a GPU or nothing else. We just run as yet another application on your cluster. You just deploy it. It creates a namespace with several pods in it, and that's Sosivio, meaning you don't have to prepare anything for it. The second very important thing is you don't really need anything changed in your deployments, in your pods. There is no sidecar required for all the information that you've seen. Everything is extracted by our collectors from the nodes, and there's no need for any instrumentation or preparation in the applications themselves, in the other pods.
So
About the
you will
installation,
need you will need some PVs
no,
to no.
no, zero prerequisites.
Do you want to talk about Sosivio DB for a minute and hit on that?
Yeah, so CVDB
So
is actually an in-memory, as I said, graph and document store. It's a graph database and document store. Um, it is highly available, meaning you can kill any instance of it and it immediately replicates itself uh, back, meaning there's no, it's actually very difficult to cause data loss. If you want to zero out the database, you have to shut down the whole deployment, and even that takes time. Uh, but basically, it is super fast. It takes all the information that the collectors ingest and stream it to the right locations. It does not require any disk because it is in memory. It's completely distributed, so it's not in one location. You may have 5, 10, 20, depends on your cluster size. So CVDB instances, that's the secret of it running so fast and being so highly available. Again, we had requests for long-term storage, meaning people want to have information like for 3 days, 3 weeks, 3 months, and that will require a PV or PVC naturally. But right now, Sosivio, by the way, Sosivio also doesn't save information for that long. We don't need it. The idea or the concept is, if a pod died just now, the information from it is relevant for, let's say, 30 minutes, 1 hour. After 1 hour, it's irrelevant because either there's a new pod or the pod is not there or someone redeployed it. So it doesn't really matter what happened. What does matter is the sequence. Like, I want to know, I don't care about all the logging information and signals, but I do care if it was OM killed or if there was a panic. Those are kept for a long period of time. Sorry. But the information from like all the logs, that's not kept. We do have requests, as I said, to keep it for longer periods of time, just for regulation purposes. And
So that's in the roadmap. Uh,
yeah,
and I would imagine that most of the information that you get, you're getting it from Prometheus and directly from the Kubernetes APIs on the various resources. So there's no, like you said, there's no need to install any other uh, agent or um,
nothing.
okay,
We do take the information from the Kubernetes API, but not from Prometheus. We have, as I said,
okay,
our own data collectors.
okay,
And
and those are installed as pods. Um,
yeah, it's a daemon set basically. It's
Deep
a
set.
daemon set that runs on every node.
Yep. Okay. Okay. Excellent. Yeah, I don't have any more questions. Have you got anything else to tell us about today regarding the technology, or some use cases that have happened to you where you have your customers with
Oh, we
this?
have a lot of use cases. Like one of the use cases, I can babble along, so stop me when I do.
It's a chat.
Uh, yeah, you saw. Let me share again for a second. So with this
Yep.
simple, you guys see my screen?
Yeah. Yeah. Now we do, and it seems to be okay. Uh,
Working.
yeah. No. Okay. I was already.
It's okay.
Um, yes. 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 Yes.
Yep.
Okay, so remember the SDN latency that I showed this? So
Yes.
this actually helped us find a very hard problem that was around for 3 months in the Israeli army, actually, that was running OpenShift on top of OpenStack, and there was a problem with Neuron, with the SDN underneath OpenShift, and nodes were spiking to 8 seconds latency, and there's no way to see it, right? It happens for 3 seconds, 100 pods are timing out. You can't see it anywhere else. We caught it here. So that's one very important. Also, DNS issues. Sometimes we had an issue where one pod was running an application. They didn't use DNS cache. There was thousands of requests to services. The DNS was bombarded on that node. Latency was like 500 milliseconds to get a resolution. We found the culprit afterwards, but just knowing that the DNS has a problem and it's loaded, that is very, let's say, first of all, reassuring to understand that the problem is just on a specific node or a set of nodes, and not on the whole cluster. And the second thing is just to find who is bombarding the DNS, which was easy because you can go to DNS logs. Um, to think of other use cases, I can go about problems, but I think one of the customers, I won't say who, they were running on Amazon actually, not OpenShift. No, it's a bad word here, but just to
No,
give you we ran application profiling and we found that they are like 80% over allocated, meaning developers, they want the pod to run. So if they need, let's say, half a core, they give a request of 2 or 3 cores and a limit of 6 cores. Everybody's happy, but the company pays, I don't know, $500,000. I don't know the numbers, right? But if you just run application profiling and you go pod by pod, you can just see the waste. Even in some clouds, we even saw requests for the Calico pods or the SDN pods that were supposed to come from the environment. They were the request was half a core for each, which they almost don't even use. So just even reducing that reduced costs significantly. Cost is a nice thing, but application profiling is the initial intent behind it was cost is a nice side effect, but the initial thought behind it was to not under allocate, right?
right.
Where the problems start. You don't want to be throttling, and God forbid you don't want to be OM killing. So we have a lot of those, by the way, a lot of examples where we put it in customers' environment and we just immediately, by the way, the information flows into the product. In 10 minutes, you already have results.
Of course, because like you said, you don't have to, essentially you don't have to instrument anything. You just turn it on and it already. So I guess over time, um, you will gain, you'll add more and more of these sequences that are basically doing a automatic diagnose of problems as they come in, or more engagement you have with customers, and then you add it uh, to the recognized patterns of the product. If that's how I understood it. I go back to my initial question: if there is an idea of allowing customers to over in the future to train themselves the system, so that I can, especially if it is application specific, if it is
Well,
something that's
we started talking about it, so to create something like the OWASP pros, right? Like something that you open to the world and everybody can contribute, and which is cool because we do, as I said, have all the sequences. Everything that goes wrong on the cluster, we find it, and letting people say, okay, I know this one. This is my application. This is how it fails. I want to keep that, and someone else can take it and maybe do a RabbitMQ, and this is how it fails in this scenario.
right.
It crossed our mind. We are talking about it. There is a lot of there is a lot of. Just a second. Let me just put it
So I
out. Sorry about
think
that.
we're getting towards the end of the hour anyway. So let me finish my. It's cold. No, no, I think it's quite interesting, especially if in the spirit, of course, of the open source, and um, but like I said, I can think of a number of projects I've been working on where one recent um, that could have benefited a lot, primarily because we're talking about very, very large infrastructures with hundreds of nodes, with loads of applications that are running on them with different characteristics that make use of storage in very, let's say, creative ways. And so something that allows you to do what you guys have shown could have helped a lot. But I can also think of Red Hat support that could contribute to those patterns as well.
Definitely.
That's something that's probably good cooperation could come out of that.
Yeah, we actually had some collaboration with Red Hat. We found in an older version of OpenShift, we find something wrong with the kubelet in one of the customers, and we immediately caught it. So we shared all the information. We had quite a productive session there with the
Yeah,
customer, of course.
and I'm thinking a little bit. There are cases when remediation, like actually solving the problem, actually does require a patch. And while you do that, you the only thing you can do is to actually watch to predict when when it's about to break and do the sort of workarounds that will keep the system running. But it's not ideal. But that's what you have to do. And so if you don't have something like that, you have to actually do a little bit of manual intervention in keeping under control certain parameters and certain applications. And it's not easy,
Right.
especially on very large infrastructures.
And what do you do with the next version is deployed?
Yeah, yeah.
You have to
So
change everything, right? That's the big problem here. You can have like a deployment every 2 weeks or 3 weeks or to 1 week, and all the parameters suddenly changed. CPU request, memory, the sequences themselves, what this pod requires network wise. Maybe it used to send just one HTTP request, now it sends 500. You don't know.
so it looks like we don't have any questions coming from the audience. I don't have any visibility. There's one that I had to take care of separately. Uh, um, and if you guys think that we can come to a conclusion of today's talk. Some final thoughts, links that
Yeah.
I can give to our so that if they want to know more about it, if you can give me some links, I'll put them on the chat.
So first and foremost, this is an OpenShift session. So we have a certified OpenShift operator. Please, you're welcome to go to the operator hub and just download it, install it on your cluster. It doesn't put anything else other than the Sosivio namespace on your cluster.
So
So
they
you
have
can,
to do is search for Sosivio on the
yeah,
operator hub.
right.
Excellent.
And it will download and run easy.
And
Other than that, we have our website. We have full documentation there. Steven,
I just copied it onto the chat for everybody to see if they want to know more. They can go there. They'll probably get in touch directly with you guys.
definitely.
There's also the docs. So I guess that's all we had time for today. And let me just copy the the email here. Today I'm alone, so I have to do everything. First of all, thank you very much. It was very informative.
Thank
We
you guys
learned
for
a
having
lot
me.
today. And to all our listeners, I'll see you all guys in the next episode of OpenShift TV. Thank you all very much.
Thank you, Andrea. Thank you,
Thank you.
guys.
There.
Bye bye.
And